Hello everyone. So in this video we're going to go over some molecular phylogeny stuff from my class, and this was basically something pretty interesting. It's making a phylogenetic tree, but you're showing genes over time, mutations in genes instead of species. Let's get started. So below is a sequence alignment with fixed differences for species A through D, so that's what we have right here. Create a pairwise genetic distance matrix and construct a neighbor joining tree, where clades are represented by parentheses. Parentheses always list the species alphabetically. Alrighty, so this is basically asking for us to draw a tree out, so it would look something, like one of these phylogenetic trees, but instead of species, we're looking at different mutations in this sequence here. So for species A, B, C, and D, there's their sequences, so we need to also set up a matrix, and then the distance matrix, you could do it for either similarities or differences. We're going to set ours for differences in the sequence, so let's start building one of those. We'll have kind of a grid here, and then also have some stuff at the bottom. We just continue it, and then at the top we're going to place the species, as well as on the side here. And then when we have A to A or B to B, we're not going to use that box, so we're just going to cross it out. And then these are going to be repeating sections, so we don't need them either. Alrighty, let's look at our differences between the sequence of A to B. So we have one difference, two differences here, so a total of 3 right now. Let me make that more clear. There's our fourth difference, and then our fifth difference. So in between A and B, their sequences had 5 differences. Let's go and check A to C. So A to C, we have 1 difference, 2, 3, 4, 5, 6, and we only have 6 differences. Alright, A to D. Gotta make sure that you count away how many spaces you are, because some of the letters, because of the font, will look like they're not aligned, so you just need to watch out for that. Alright, so we have A to D, so 1 difference, 2 difference, 3 differences, 4th, 5th, a 6th, a 7th, an 8th, and a 9th. So 9 out of 10 of those were different. Alrighty, so now, looking at our numbers in the matrix on this A column right here, we see that 5 had the least differences, so that means A and B will be paired in parentheses. So now, we set up another matrix, but we combine A and B because they're the most similar. So A, B, and then we have our C and D still left over. Alrighty, and of course we won't have an A, B to A, B, C to C, or a D to D, so those aren't going to be necessary. Alrighty. We could also just fill in the rest of this chart because we will need that for later. So next one will be B to C. We have 1, 2, 3, 4, 5, 6, 7, 8 differences between B and C sequence. Now B to D, so let's compare this one to this one. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 differences as well. Alright, now we just have to compare C and D sequence to each other. We have 1, 2, 3, 4, 5, 6, 7, 8 differences. We'll need those numbers here in the matrix for later on. Alrighty, so now we get to the interesting part where we're comparing A and B to C and A and B to D to see which one of those species will be the next most similar. Alright, so how are we going to do that? So for A, B to C, we actually have to take the average. So in that box here, so A, B to C, we will actually be doing A minus C, A to C, or A minus C, the difference of, and then plus the difference of B to C, and then over that we'll do, it's divided by 2 since we're taking an average. So first we have A to C, which is 6, so I'm just going to erase that and put a 6. Now B to C, we have an 8, so 6 plus 8 over 2, it's 14 over 2, so A, B to C is a 7. Right, next, let's do that same formula, but we're going to do A to D plus A, or B to D. Because we're going to look for that average when we're comparing A, B to D. Alright, so A to D was 9. And then B to D was 8. So 9 plus 8 over 2, that's 17. So that's 8.5. Alright, now let's do C to D. We already have that, and it's just 8. Alrighty, so out of these numbers, we have the lowest number out of all of them is 7, and that was when A and B was compared to C. They had the least amount of differences, so therefore that means we're going to have our already paired A to B, then we're going to have C, and then our last species D is the most different out of all of them. So this will be our answer. And this would look like a phylogenetic tree. You could draw it using these parentheses and this notation. That would look like A to B as one group here, so A, B. Then since C is its own thing, it's going to get its own sort of branch off of that, and then D is going to again have its own branch since it's not confined to a parentheses grouping like A to B was. That's how we know it's separate. So that's what the tree would look like. Right, so let's say in a hypothetical situation we had that number there. Let me change the eraser first to something smaller. Let's say if we had 2 5s over here. So we both had 5 for A to B and A to C. With this new matrix number, we would actually be in this situation, which is A, B, C, and then D is the only species that's excluded from that group. So there you have it. That's how we figure out these matrices. Please do something nice for someone and have a good one.